10.5, the Millikan experiment determining the elementary charge. Okay, so in this experiment, we have two parallel plates, one negative, one positive. Here is connected to the battery. The battery will provide a potential difference between these two plates, delta V. And the separation between two plates is R. We suspend a drop of the oil. It recharges with a positive charge Q is here. We increase the voltage in such a way that this drop of the oil will be suspended in the middle of these two plates. Basically, it's just hovering here. When that happens, it means because there is just two forces. The positive charge will attract it to the negative plate, right? So if electric field is upward and we have a mg, the weight of that is force of the gravity is downward. You increase the voltage until this electric field becomes strong enough. So this upward force cancel downward force. That's why it's two force canceling. We have an equilibrium and it's staying there. Okay, so this experiment helps us to find how much charge is on the sphere, on this drop. So we know force of electricity Q multiplied by electric field. Also, we know force of gravity is mg. So since it is these two forces need to cancel, so f of E is equal to f of g. F of E is the QE, f of g is mg. Also, we know electric field is delta V, potential difference between plate divided by the separation of that. So instead of the electric field, you put delta V over R. Here we put Q delta V over R is equal to mg. We bring delta V and R to the other side, so it's mg, R going top and delta V going down. This is what we have here. We have the mass, we can find the mass of the drop of the oil. The G is 9.8, R is the separation between plate. We have a delta V, you can read it from the device, so we really can determine the Q. When the Millikan did this experiment, he did it with different weights, and he found that each of those, when he want Q, the Q is a multiple of this number, 1.602 10 power negative 19. So this is the charge. This is the charge of the one positive charge or electron. So Q is equal to NE. N is the number of the charges or electrons, and E is the charge of each electron. The number of that multiplied by charge of each electron give you the net charge. Calculate the charge on a small sphere with the excess of 5 10 power 14 electrons. We have that many electrons, and each electron has charge of 1.6 10 power negative 19. Multiply them, we will find the net charge. Here, Millikan type experiment, two horizontal plate is 2.5 centimeter, so is R, you can turn it to the meter. The lattice sphere of the 1.5 10 power negative 15 kilogram remains stationary when the potential difference given delta V is given, the mass is given. Is the sphere charged negatively or positively? So it depends on what we do. The electric field must be up to balance the downward force gravity. Since the upper plate is positive, so if the upper plate is positive, see, and here is negative, the lower plate is negative. We know the force of gravity is F of G downward. So of course, the force of electric should be upward if they wanted to cancel. So therefore, this Q here need to be attracted to positive. So it should be negative charge then for it to be attracted to the upper plate. So here, calculate the magnitude of the charges on that. So we know that equation, we had discussed that Q's mg or delta V m and g and or delta V is all known. Find a Q. How many excess deficit electron does the sphere have? So you just need to know that Q is n multiplied by E, so n is Q over E. Q is given divided by electrons 5 electrons. Practice, you can do question 1, 2, and 3, and here 4, 5, and try.